Okay, children, we move on to another important concept called feedbacks. I use this word already many times, but here it's called vicious circles. Maybe you're too young to know what that means, but if you're old enough, then you know approximately at least what that means. So we'll see what that means here. Everything about the climate on the earth is connected. For instance, ocean currents affect air temperatures because it moves heat from one place to another, cold from one place to another. Air temperatures affect plant life. For sure, if it's cold, crops can die or wilt, as they say. If it's nice and sunny, there's photosynthesis and they can grow. Plant life affects the atmosphere. Why? You already learned that it releases water vapor when the stomata under the leaves open, and it takes up carbon dioxide to do photosynthesis, so it's directly affecting the atmosphere. And the atmosphere affects the ocean currents in turn, because the winds are blowing and heating the water and cooling the water, and currents are being produced, and then the currents are affecting the atmosphere. So it's all like a full circle, except we'll see that it's very complicated web of connections. Okay, so that's a vicious circle, so then you can think of it as a circle. Usually when we say vicious circle, we mean bad things. I don't know what example to use depending on how old you are. Let's say you started to eat candy which has a lot of sugar, and your mom keeps telling you that's really not good for you, but once you eat a candy, your brain says, wow, I love this, and it demands more candy. Then you are bugging your mother and saying, Mom, give me more candy, and this is called a vicious circle. To put this idea in general terms, A makes a change in B. Let's say sugar makes a change in you, which in turn changes A, which means your brain says, I want more sugar, so then you get more sugar. Then it changes B even more, which means now you are eating even more sugar and then demanding more sugar, and so on, and before you know it, it's bad for you. So it becomes a vicious circle or a never-ending loop unless your mom says, that's it, no more candy. Right? So melting ice and snow are one example. We talked about ice-albedo feedback already. Ice and snow are clear and white, so they act like mirrors, bouncing sunlight off their surfaces to keep the earth cool, which means sun's energy that is coming in and heating everything can be reflected back to space, so that energy is not doing any work. So ice-albedo feedback works with this basic idea that ice is very reflective, and if you remove ice, everything else is less reflective, like land or ocean or vegetation or city centers and so on. But when temperatures rise, sea ice along with land ice and snow melts. There is more open ocean and more uncovered land if you begin to melt the glaciers and the snow and the sea ice and so on. And these are darker than snow and ice, which means their albedo is lower, their reflectivity to the sunlight is much lower, which means more of the energy is being kept in the system, which means it's getting warmer, which means more snow and ice is melting, which means again albedo goes lower because you expose darker surfaces and so on and so forth, and before you know it, you're melting away the snow and ice, right? So this is how we would see it. Sun comes in, there is some energy that is being absorbed by the darker surfaces and some that is getting reflected by the brighter surfaces, and the snow is, you can see the scale of the arrows, there is some absorbed and some reflected. But if you have ice and snow, the absorbed part is much smaller than the reflected part, as opposed to grass over here, which has more absorbed than reflected by the size of the arrow. So if you melt away the snow, then you're going to expose what's under it, which is darker, which means again absorbed will become more than reflected, and it will make the land or the ocean warmer and the atmosphere warmer, and which means it'll melt more snow and so on. So have you noticed that when you wear a black shirt you feel warmer in the sun than if you wear a white one? Maybe you haven't noticed. If you want to do that experiment, be careful. Talk to your mom. Dark colors soak up heat, so the darker ocean and land act like sponges absorbing energy. We call it the albedo, ALBEDO, which we have discussed in the other sections before, so you can go and listen to these podcasts. That extra energy warms the earth, which causes temperatures to rise, which melts more ice and snow, which exposes more ocean and land, which is darker. That means atmosphere and land and ocean get warmer and so on. The effect is especially serious in the Arctic tundra. Tundra is a kind of forest that you can Google and find out. Tropical forests have all these tall green trees and lot of stuff on the ground that are growing, and creepers climbing on the trees, and birds and monkeys going around. In the Arctic tundra, vegetation is low to the ground. It's sometimes colorful and full of green grasses and red flowers, and there are some cold climate animals like elk and moose running around eating whatever there is. There are rabbits and foxes and so on. So there is permafrost disappearing. Permafrost, as we said before, is frozen soil. When the temperature remains very cold, the water in the soil freezes. The soil freezes, and we call it permafrost. Okay, and if you keep warming the temperatures in the atmosphere, the soil is not freezing as much before, and it starts thawing. It becomes less frozen and keeps going deeper and deeper, and frozen soil is very solid and almost like a rock, but if you make it warmer, it becomes squishy and things can sink, as we saw before. So the permafrost, which has been there for millions of years, also holds methane, rotten material that was photosynthesized. Methane is a very powerful greenhouse gas. In fact, it is much stronger than CO2. What does that mean? It means it traps even more thermal energy going out than CO2 can. It's like having a much thicker blanket than a thinner blanket of CO2. Methane doesn't stay in the atmosphere as long as CO2. We said CO2 can last for many centuries, but methane lasts hardly 10 years, but it traps about 30 times more heat. Okay, so if you're constantly producing methane and putting it in the atmosphere, and it traps 30 times more heat, it doesn't matter that it only lasts 10 years. We'll be replacing it with more methane. When the permafrost or the frozen soil melts, methane is released. The temperature goes up because methane is a very powerful greenhouse gas. If the temperature goes up, more permafrost melts, releasing more methane, and so on, which we call a vicious circle, or in science we call it positive feedback. You perturb one thing, it amplifies something, that comes back and amplifies the initial perturbation, like melting the permafrost, and you are in a growing feedback, which is what we call positive feedback. Can you think of a negative feedback? Of course you can. If you are living in a house with a heater or a cooler or air conditioner, somebody is setting the thermostat and say maintain the temperature at, let's say, 24 degrees centigrade or higher or lower, and let's say you are cooling with an air conditioner, like Mumbai now on May 30th is very hot. The air conditioner will kick in if the temperature in the room goes above 24 degrees, which you have set, because there is a thermostat. The thermostat senses the temperature and tells the air conditioner it's getting too hot, better start blowing cold air. Cold air starts blowing and the room temperature cools, and if it drops below 24 degrees centigrade, which is what you set the thermostat to, then the thermostat tells the air conditioner, now stop blowing cold air, so the air conditioner goes off. So here it is a stable. If you don't understand what stable means, it's okay. It is a negative feedback, which means temperature is not allowed to go away from where you set it at 24 degrees centigrade. But if you have a positive feedback, then it will keep getting colder or warmer. Okay, so the more Earth warms, scientists realize, the quicker more warming occurs. In other words, higher temperatures lead to even higher temperatures. It's one more factor in the science of climate change, but some people don't believe in the science. How can it be? Well, it's complicated. They don't believe in climate change at all. You can ask your parents whether they believe in it or not. Okay, so this is the discussion from the book, but I will add some examples of what feedbacks or vicious circles there are in the Earth system, and we'll look at some example with figures. Already we looked at the example of permafrost and methane and snow melting and reflectivity reducing, but we'll look at some other complicated loops to understand that the climate system or the Earth system is complicated. So we'll come back and do that in the next podcast then. See you.